regular size candy bar was normally distributed with a mean of 4 and a standard deviation of what? I don't think I have a pass. 0.15. Yeah, at your own risk. And a king size candy bar is approximately normally distributed with a mean of 7.5 and a standard deviation of 0.4. Okay, so we have our these are the two random variables we currently have. We're looking to define a new random variable. Our new random variable, can I just call it x and then define it as a linear combination of these two? Okay, now a linear combination of these two, it says what is the probability that a randomly selected king size bar weighs more than two randomly selected regular bars? Okay, so before I define x, I'm going to think through the probability part of this. So if a king size bar weighs more than, what math inequality symbol is that? Greater than 2r or r plus r. You could say 2r, right? Okay. King is greater than 2r. So now get everything on one side. So like move the 2r over, minus it. So king minus 2r is greater than what? 0. You could do it either way as long as you can interpret it correctly.
So the new variable x is k minus 2r.
The new variable is k minus 2r. Yes. And I actually prefer, just for computation's sake, to write it as k minus r, but it really doesn't matter. Okay. I think you'll make less mistakes on the computation of the standard deviation if you write it as k minus r. I really do. So, all right, so now this actually, well, after we define this new variable, we're going to be finding the probability of this, that k minus r is greater than 0. Okay, how does that work out? Because if a king size bar weighs more than two regular bars, wouldn't this difference be positive? If the king size bar is still heavier than the two smaller bars, if you subtract king minus 2 regular weights, wouldn't you still be positive?
Yes.
Okay, does that make sense, how that probability is what we're looking for? Okay. So let's define this new variable. We need the mean of x, k minus r. So how do you find the expected value?
7.
You're going to take the expected value of the king size, 7.5, and subtract 4 twice. So what would be the mean? Negative 0.5. So k minus r is approximately normally distributed with a mean of negative 0.5. And now we need to find the standard deviation. So we take the variance of the king size. What's the variance of the king size? 0.4 squared. Plus the variance of a single regular, 0.15 squared, plus the variance of another regular, 0.15 squared, because variances always add. That is a rule from last time, okay, and from reading your book, okay, and then you square root, which most of you are lying about when you tell me that you read your book.
Wait.
I would never tell you that.
I will never tell. So
Okay.
we're still doing k minus r.
We're still doing k minus r. Why is it plus? Because of this rule from last time. Variances always add. It was reinforced. Where is it?
So wouldn't there be 2 4s and not 2?
Yay!
No, because we're taking 2 regular size bars away from a single king size bar. Okay. All right, so now do this calculation. Tell me what you get for the standard deviation, please.
0.45.
0.45?
Yeah.
Okay, so the standard deviation is 0.45. So here's our new random variable. So we could, I'll try to squeeze this little picture right in here. Negative 0.5, and this is ounces. See, that way I've got it labeled right up above. Okay, I've got it labeled right up above. I need to put my 3 standard deviation marks. And I need to add 0.45. So negative 0.5 plus 0.45 is negative 0.05. No. Yeah? Is that right? And then add 0.45 again. What do you get? 0.4. and then add 0.45 to get 0.85. Okay, take negative 0.5 minus 0.45 is negative 0.95. Minus 0.45 again is negative 1.4. And then minus 0.45 again is negative 1.85. Okay, so there's our picture. And we would like to shade in what is our x value. See, let me show you, refresh what we've done. Okay, summarize what we've done. We had two random variables, regular and king size. We were taking a king size minus 2 regulars. We just defined that variable. Now we're working on finding this probability. So the x value, the number we put here, is at 0. So where's 0?
On the top.
Isn't it like right up here?
Yes.
0. And we're shading greater than that. So up here. So now in our calculator, I'm going to do NCDF. What's my lower bound? 0. What's my upper bound? 99999. What's my mean? Negative 0.5. And my standard deviation? 0.45. Hit enter. It should be something, less than 14, 15.1. 1333.
Yep.
0.13326036064.
Okay. Okay, are there any questions on that?
Nope.
Okay. So that's really the new material. Now what I'm going to show you
It's easy.
is how to get your calculator to find the mean and standard deviation of a probability distribution for you.
Wow.
No,
Really?
not kidding. Not kidding. So, you know those like the battery problem we did?
Yep.
Oh, that's really zoomed in. Okay, so the battery problem we did, once we have the probability distribution, if you know how to do this, if you pay attention now, I'll show you how to find the mean and standard deviation using your calculator.
I bet we use tables.
You're right. Okay, good job. Okay, so here we go. This is a probability model for grades on the AP Stats test at a school in Colorado. And so the scores, basically your AP test scores are scored 1 through 5, if any of you have taken an AP exam. So the possible scores on a test are 1 through 5. Thankfully they don't give zeros because I think they'd have to give a few, but okay. So these are all of the probabilities, so those should add up to what? 1, they do. Okay, so now to find the mean and standard deviation, here's how you do it. Using your TI, so go to your lists, enter X's in list 1, enter P of X's in list 2. These are the instructions on using your TI for this. So you doing that right now?
Yeah.
Sure.
Well,
How? How do you do it? I would type in 1, 2, 3, 4, 5 in list 1, and go to list 2 and type in 0.03, 0.04, 0.24, 0.43, 0.26.
do they add up to 1? Yes.
Okay, we already discussed that.
Yeah.
All right, so now I enter them in the lists. Now what I want to do is I want to go to Stat, Calc. Well, first of all, I want to go to the home page first. So second quit, home page, clear it, and then I'm going to go Stat, Calc, Stat, over to Calc, and then I want to do one variable stats, Stat Calc, one variable stats, and I want to do it for list 1 and list 2. So one variable stats for list 1, comma, list 2. That's what you need to do it for. So your calculator, so I'm going to go one variable stats, list 1 is list 1, list 2 is the frequency list.
You should
Will I what? So stat, calc, one variable stats, list one is the X list is the list, list two is the frequency list. Frequency is how many times something occurs. It's like a probability. So do any of you have a calculator that do not show this command? Okay, so if you have a calculator that shows the command that says one variable stats and then it gives you parentheses, you type in list 1 comma list 2 and hit enter. That's all you do. You're giving it the same commands, it just doesn't prompt you for them like some of the other ones do. You should get, so then if I just go down, hit enter and calculate this, X bar, wouldn't X bar be the mean?
Yep.
So X bar is the mean of X, is the expected value, is 3.85. And the standard deviation, notice how it only gives you one of the standard deviations. It does not give you the sample. It gives you the actual sigma, which it should. So the standard deviation is 0.95. So now that I know that this distribution here has a mean of, I'm going to write that differently, it has mu of X of 3.85 and it has a standard deviation of X of 0.95, I can now use that to find the mean and standard deviation for the sum of 3 randomly selected scores. So now we're going to combine random variables. So what's my new variable?
X plus X.
Define new variable, X plus X plus X. So the expected value of X plus X plus X would be what? 3 times 3.85 or 3.85 plus C 3.85 plus 3.85. So 3.85 times 3 would be 11.55. So that would be the mean of 3 randomly selected scores. And the standard deviation of X plus X plus X, well, let's see, that would be the variance squared, right? What's the variance? Well, not the variance squared. What is the variance? 0.95 squared plus 0.95 squared plus 0.95 squared, and then do what with that? Square root it. Or 0.95 squared times 3 and then square root it. Same thing. Which is what? 1 point, I don't know.
Yeah, that's what I got.
1.65? Okay.
Oh, just standard deviation? Oh, never mind.
Okay. Now, note, it actually, you have to show some work for expected value calculations on the exam. So you do need to know you do need to show some work. So what we did up here actually wouldn't get you full credit. The very least you would have to do to get full credit for this would be to write the formula down. So the expected, you would have to write this, so for this little note right here, you would have to write the expected value is mu of X is the sum of every X times P of X. That's what you'd have to write down. Yep. Sure can. So you'd have to write that down, and then you could just write it equals 3.85. And then you'd have to write the standard deviation of X. You'd have to write that formula down, the square root of the sum of every X minus mu of X squared times P of X. And then write that that is 0.95. And these are formulas that are given to you on the AP notes page. So you don't have to memorize these. They are given to you. You just have to remember to write the formulas down if you're going to use your calculator to find that.
Could you write the formulas down?
You could just-
plug the numbers in.
What do you mean?
Like actually plug in the numbers that you're going to use rather than.
So you're like show the formula written out?
Yeah.
So yeah, another perfectly viable option would be to write E of X equals 1 times 0.03 plus 2 times 0.04 plus 3 times, plus 4 times 0.43 plus 5 times 0.2. That's, I mean, just to write it all out, and then you could use your